Good afternoon, welcome to this webinar on the Building Design Suite. We're going to cover everything from concept through to construction drawings. So we're going to take our architect's drawing and we're going to go through on into analysis and design of our multi-story building or other type of building. My name's Tommy White, I am the sales manager here. What I want to do first of all is just to work through a little PowerPoint presentation. Won't take long to run through what it's all about. So here we go. The Building Design Suite. The Building Design Suite is a modular multi-material system that can import models from DXF, Revit, Tekla, IFC. We can then do wind analysis on complicated multi-material models. We can produce drawings, we can send those models back out to Revit, as we'll see in a moment, and we can then hook in the design components that we require to do steel, composite, concrete, timber, connection design, even advanced dynamic analysis for mode shapes, vibrations, response factors, all of that, all inside the one interface. And of course we can then send that back through into the likes of Revit and IFC format files through the Tekla, and we can also produce RC details and even simple DXF details. So the nice thing is you do not need to buy everything, you take what you need, and we'll explore that in greater detail near the end of our webinar today. Just press escape from that and close down that, and if you're wondering, that is our new offices, 6,500 square feet we're in now. So what I'm going to do is I'm going to go to my Revit models. I actually have them over here, sorry, my other screen. I'm going to pull a little Revit model. So we can take a Revit model from the architect, from the fabricator, from whoever, and we can go into our own add-in, Master Series Link Manager, and we can create a link, or we can save a link settings, or we can submit changes to the link. So this is a special little add-on we put into the Revit to allow you to submit all your data, and it's sending that out to Master Series. And we can see we exported frames, columns, walls, two material types, 33 sections, one floor, some grid lines and levels, and everything. So just close that down. So that's coming out from Revit. And just to save time, I will in fact show you the model come into the Master Series. So here we are in Master Series, looking at the same model that's come through with all its cellular beams, and I think we'll find we did play around with this. We do have a large section here. We've got some finite element shear walls, and we have some haunched members all coming through nicely into our Master Series model. We can also handle the IFC format, which is used by Tekla and others, and we can bring in models there. And you can also start from scratch, bring in a boring DXF file, use it as a basis for your model, and draw over it and import your wireframe from there as well. As well as importing models from predefined systems, we can also generate and draw our own models, and it's a very, very straightforward CAD style application. So if I wanted to go in and create a new member, I can come in and I can say I want to put a UB, and I want to actually put in a column. I'm going to say UC, and it's going to be 203, 203. So what I'm going to do is I'm going to put it over here, out here, and that's snapping because of this grid and this, and then I'm going to raise it up, and if I just rotate this around, I will then be able to see that I'm snapping across there. So that's that column. I could of course have rotated it through 90 degrees beforehand, and if I just do that again and then repeat, we'll see that it's now in the same orientation. So flicking over to a beam, and we'll take a nice light beam. As you can see, I've got all the different section sizes and different types. I can now do a member, and in this case it's been rotated through 90 degrees. So just come back, 0, draw it again, and continue. I can also draw things into other frames. So if I was to come along and say that I wanted to put some trimmers in here, I can just choose something very small, like not a W section, a CHS, and put in something very small here, say a 60 by 60. I can come in, and if you look carefully, I can snap in this case at 100 mil centers, but I can just run along and I can type in 1.258, press enter, and it knows that that's my start point, and then I can come orthogonal to that, and I will see if I turn on my lengths that that is the 1.258 length, so I can override any distances. I have some fantastic tools in here for generating, and I definitely don't want to see my lengths anymore. If I take, for example, this sloping member, I could create, and we just stay with a circular hollow section, I could create another member coming down, and I can say I want to hover, 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 and I get that as a member reference. There we go, and I can now use that, and I can say at that slope I want it 1.9 meters long. So it's now drawing it at that member slope but coming out. So I have all the standard AutoCAD type tools, plus some more that we feel are relevant, and we're generating our members as we need to, and we can create plane frames, space frames like this without any problems whatsoever. So moving on, and if we look at this little frame in more detail, we will see that we already have the grid lines came in from the Revit. We also have all our levels input, and we have some panels already generated. But I'm going to close this down because I want to look at some typical frames for a moment, just to give you an idea of the sort of stuff that we do, or should one say correctly, our clients do. So I'm going to open a file. I'll not save this. So I'm going to go into here and look at some typical frames, roof frames, a two-story building, nice multi-story buildings, a lovely building with a curved front facade, a school on 3 floors, and then we have another office block with a lot of overhangs, and a nice multi-story, I believe that was apartments. So we can do quite a range of different, what was that one? Oh, no thank you. Very, very complex models. This is just some of the stuff that our clients themselves do on a daily basis using this system for us. So I'm going to cancel that, and I'm going to close this down because I don't want this anymore. And just to save time, I have another frame analysis in the background I'm going to work on. So just close that down and pop this one up. So this is the little frame I'm going to work on. I'm going to walk you through this frame, and we're going to look at everything that we can do inside this frame. This is not a typical frame, because when we turn on the 3D, we will see, first of all, we have concrete in grey, we have composite beams in yellow, steel in green, and we also have these big FE shear walls and flat slabs, and we have a shear core with some nice openings put through it, and if I rotate it you'll be able to see with the shading all the openings. And just because this is a frame I've used before, this is an old style rigid link type of members rather than the FEA. So if you're a smaller user and you want to use just a simpler method, you can. And because this is claimed to be multi-material, I have up here got on my roof a portal frame with some bracing, and I just, for the sake of demonstration, put in a nice timber truss. And since it's a demonstration, I made the top and bottom members flitched beams. So this is a flitched beam with 2 plates on 1 wooden beam, and the top one is 2 beams and 1 plate. So we can do both styles of flitched beams. We can also do them top and bottom if you so desire. So that's my basic frame. Not that basic, and we'll see we also have cell form beams and we have asymmetrical beams in the system. So now, moving on, the next thing I want to look at is the loading on the frame, because that's one of the big things. It's easy enough to bring in the model from your CAD package or your architect. It's easy enough to put the section sizes on. The next thing you have to think about is getting the loading on the frame. In the old days, you obviously went member by member, not any bit more. And these modern systems allow you to do something called area loading. So I'm just going to go back to wireframe. It just makes my life easier. And I'm just going to now look at gravity area loading. And the first thing we've done, using my levels over on the left hand side here, 1 to 6, I've set up at each level the designation and what the loading are: services, mesh, density, and need to see the loads, superimposed, dead plus live load. So we're seeing a 5 kilonewton load on the first floor. Second floor, second is the same. Third floor is only 2.5. Must be domestic use rather than commercial. The roof is 0.75, and then the plant roof is 0.6 and 0.25. So we have been able to set up on each level what we want to use for the loading. And that's great. We've also been able to tell it whether it's composite, and we can see that it is not composite on the portal roof. That's, thank goodness. So I'll just close that and moving on. So what have we done with these? If we turn on our area loading and draw the gravity area loading, we will see that we have got different intensities on each level. We'll see that out here we've got a different intensity here because we overrode the default for the level and said no, out here it is only 1.5. We can also apply in patch loads. So somebody has put in a plant patch load out here, and we also have the ability to place line loads. So if I was to rotate around, I believe somewhere somebody might have put on some line loads. I believe that there were some line loads, but it must have been deleted, not to worry. I can put a line load on very quickly for you. So that's how easy it was. And sorry, apologise there. I'm just going to turn all that off and come down into a level. So let's go and view level 2. So this is my level. I'll just put it into an ISO view so it looks nicer. That's just coming up from the shear lift shaft. We'll not worry about that. But coming through into my areas, I can now look at the panels. So I can see this panel's been defined, and if I just go and find this level and I just click on this one, and I can see that we're all spanning this direction except for these ones over here which are spanning in opposite direction, and that's because I told it to go by shortest. If I wanted this one and this one also to span the same direction, all I would need to do is go and make local change, choose the panel and change the direction to be that way. Take this one, change the direction to be that way, and I've overridden that. And while I'm here, I might as well put an additional 2 kilonewtons of additional load onto that panel. That's how easy it is. And if I wanted to, I could then copy that over to that one as well. So I've now changed the loading on those. I said about line loads, so let's put a line load on here, and let's just put a line load along this back wall. So I'm going to put a line load here. I'm going to put it all the way along here, and I'm going to give it intensity of 12 kilonewtons. So 12 kilonewton line load on that level, and I can put those internal, external, wherever I want, and have done with it. So now we have changed some of the areas and made local changes to the loading. So let's go back out to our full frame and look at the area loading again. And we should see when we put on our patches and points, we now have this line load, and I don't really want the values on it, just not as pretty at the minute with the values. And we'll see back around here on level 2, there's the two panels we changed the direction of and applied an additional loading onto those panels. So loading is very, very simple to apply and very, 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 very powerful. So that's in your general frame. The other area we want to look at here, and if I come down the first floor and turn off this off, is the fact that we have FE meshes. So we have an FE frame, and if we go into the mesh, we will see that this is all one area, and I'm just going to ask it in the viewing options to show the FE meshes. So we're only looking at the FE panels, and we should be able, when we come outside, be able to see the meshing itself, because the meshing is not important at this point in time, in fact. So if I now go in and look at the FE editor, I will see I have my surface, there we go, and I also have attached beams around this, and I also have openings. So I have an opening here, and I also have my loading applied, several different loads, some interesting ones, some line loads on this to the FE surface, a couple of point loads, and an awkward line load on the FE surface. So it's very, very flexible and powerful. And if I now come back out to the full frame and just go back and in the viewing options ask it to show everything again, thank you very much. Now I'll just turn off my grid lines. The next area is wind loading, and that's obviously another minefield. So if I go into my wind loading, I can go in and say where the building is. If I'm in the UK or Ireland, I can immediately go into either my GB site or my Irish site and locate my building, which is looking to be, if my guess is right, up near Dundee somewhere, I think. I do have some basic towns I can choose, and if I go Dundee, no, I was a bit too far up. I was probably Aberdeen I was at, and not to worry. So we're now in Dundee, and we can see our fetches, we can see the topography, the orientation of the building, everything in here. We can see our roughness factors and our altitudes, all the details, and we can come down and we can see here all the different pressures at the different levels in the structure. It's automatically pulled all that out. So all I need to do now is, having chosen my site, is to apply the wind loading services to the members. So let's look at the wind panels. And don't know why I've lost a wee bit there, just a second. And I pull that back again. There we go, Windows just wasn't updating the screen. So these are my little wind panels that I've got on the structure, and if I look at them all, you'll see that I have quite a few different panels all generated. So what I'm going to do first of all is just kill those and kill them all. So I have no wind panels, and I can come along and add a panel, and I could say it is from there to there to there, and even these. Well, it doesn't like those because those aren't part of the same group, and up to there. And I can say I'm going to span horizontally or vertically. I'll stay horizontally because it's going to be sheeting of some sort. And I can then go and do another one. But of course we don't need to, because what we can do is delete all that again. Ask the program to have a go at finding all the panels itself, and in a few seconds it's identified that these are curved surfaces, and therefore each facet has its own surface. And you'll see we have a parapet separate from the rest of the wall, and we also have here a canopy, and we then have our dual pitch roof loading. So that's my wind loading all done automatically, very simply and very professionally. So let's just display that again outside here, and then let's look at our wind loading. So we can see the pressures with our high suction getting lesser and lesser to come across the structure. And if I turn on my Q values, you'll see it's 0.6 coming down to 0.2, and we're getting another capture in here of this due to the re-entrant corner. Wind blowing in this direction, we're going high pressure down to low leeward, and then again in the opposite, and we'll see all of these coming through nice and neatly. And then with the internal pressure, for if we want to consider internal pressure or even internal suction, all these are all automatically calculated for you, and you can even look at the coefficients rather than the actual intensity values, and away you go. So that is so simple in its generation. Now lastly, in the analysis end, we need to look at loading cases. So loading cases, we have our loading combinations, very straightforward. We are working, and I must stress, we work primarily the two design codes, British and Euro codes. We also have South African, but our primary codes are the British and European. We do not do American, and we do not do Indian codes. I know that was a question that was asked to some people, and I apologize, I should have said that earlier. Now, so you have all these different lovely loading cases and permutations set up, including sway stability as an equivalent horizontal forces and notional loads to check out the stability of the frame and all that. They can get quite complicated, but we also have this system where we can come along, and let's just come onto this screen, and we can generate different permutations of loads. As you can see, we elect to use 610A and B, but you can decide how you want to do it and apply all the values. But I'm not going to do that because I've already analyzed this frame. So I'm just going to say cancel. So loading combinations, superb. We can also do the P delta analysis. You can have plastic analysis. You can say this member could form hinges, and as it analyzes it up, it will form the hinges and redistribute if required. So I'm just going to come out of this, and I'm not going to save it because I just don't want to spend the time on the reanalysis. So there's my frame, and in case you haven't gathered, all the different colors represent different section sizes. Now I'm going to turn off the multicoloring, and we want to look at output. We naturally have all our tabular output as you expect, and we also have graphical. So in wireframe, there's your FE mesh, by the way. You have all your bending moments. So if I come back out and change the scale, you would see that yes, that kind of makes sense what's happening there, and you'll see the moments around the edges of the FE slab because we're doing a combined attached to beam analysis. And we can then go in to the shell elements for our surfaces. So I'm just going to look at planet level 1, and the first thing we're looking at here is I'm just going to come down and look at one of these loading cases, and I'll see my maximum MX moments on my structure. I will also, just to give you an idea, I always think it's an idea to check the movement of the structure, see how it's working. This is our deflected y-axis, and if I go to contour map, again I can see how that's working. So we're under all spans loaded here. If I do my alternate one, so I have max here, min, max and min. Obviously this one's got a big opening, which does compromise its stiffness, and therefore it does want to go down. But if I then switch over to the second alternate, you'll see min, max, min, and oh, that's not very happy, max. And then of course we do the same in the opposite direction. So we get our maximum over here and our minimum here, I believe. Or is it the other way around? No, it's minimum here, maximum here. And then we flip that side and do the opposite there. So we're able to do all our nice patterns of loading on our FE shells. So that's your displacements. That was your MX. More importantly is the MRX and MRY, the wooden armor moment. So we can see the big spikes here. And I have already asked it not to do peak smoothing. With peak smoothing, we can take out the big contours. So if I go 3D, you'll see, actually 3D color's nicer, the big peaks here over the column heads. And I didn't mention before that my superstructure columns are not coincident internally with the ground to first floor columns on this slab, so there's big problems there. And then the more important thing is to look at the reinforcement. So area top, we can see where the reinforcement is required. And from this you might decide, well, let's put in, coming down to the greens, 1330. But we also have a lovely additional tool that we can use in the FE as part of it, just coming out, and that is these strips. So if I look at my strips, and did I save my strips? There we go. That's strip 3. And if I look at my MX or my MY, we will see the nice diagram. So if I go up to the MX, and that's spanning that direction, so if I come down to MY, and I'm just going to scale that up a wee bit so you can see it. So 313 is my major moment here, and 335 there. So designing for that will certainly work, but that's really overcooking the whole thing because that's a point peak moment. What we can do is we can do a bit of peak smoothing. I can say is clip these to 0.5 of a meter and apply. And we're down from 300 to 225. But more importantly, we could turn around and say, well, I want to average this over 1.5 meters. And that's pulled it right down. So over 1.5 meters of column strip, you only need to design for 200, not 315 of force. So these are all very, very powerful, useful tools for designing your slabs. So that's just a wee bit inside the FEA. So let's now move on, and we are at past, so we've looked at analysis and FEA in the first half hour. We now want to cover all our design. So closing that and coming out, we want to go into design. Let's go back out to full frame, and first of all let's look at steel design, that my member here. And if I just go and say, right, let's look at the roof, because really the roof is the most important area, because most of the rest is composite. So what I'll do is I will just go for roof plan. That's the plant room roof, so down one. So we're now into the first floor, and I can see each of these members is giving me capacities. Some work, some don't. So first time round, I can come along to this member and I can say, you go and auto size that. I can also ask it to auto size all the visible members. That's brilliant. But just for a second, imagine we have auto designed it. How do I know that they're all working? Well, that is where we use the fail button. We can scan this view and it's going to run through and find for me if any members fail. And just while it's doing that, there's no, I think Martin has looked after all the questions. Only 2 members fail in this area. And it takes me to the first one that fails. But one of the nice things is we can then move to the next failure each time, and we can go between the two members that failed. So it's this one and this one. And then I can actually, and just put it back into plan view, I can now see all my unity values for all the members except for the one I'm looking at. We can see that fails by a value of 2. That's failing by 1.8. I can now reduce that to the most critical for each section size, or more importantly, just to the failing ones. So I can go to that failing member and ask it to resize. Go to this failing member, and it's oh so tight. Ask it to resize, and about that effective length, because it's taken all the intermediate members and used those. It's used those to restrain the members automatically. And we can see this works. So that's a 54 section, but I could possibly, by scanning and sorting by weight order, get down to a deeper member that would work, and I might just do the same over in this member as well. So that was that member. Back to this one. It is, well, it's a very light section because it's in the roof anyway, so not to worry. But the others are sorted by weight order. I wouldn't like to go any lower than that. And we have tools that can allow us to filter. So we can actually say in our design, never give me anything less than 130 wide flange. So I can limit certain criteria, or I can tell it never give me a depth greater than 500. So 457, great. 533, no, won't like it. So we have those sorts of tools and facilities as well. From an output point of view, if I was to go, it's just telling me that I should reanalyze because I've changed something, but I'm just going to scan for visible, and it's just going to walk through these, and it's going to give me the unity values of all of those, and it's just trundling all the way down through them, thinking, and it's then going to highlight the ones that are failing. We've done our design of steel. We can then go in and look at our concrete design and say no, we're not going to do our pad foundations anyway, we're going to have it onto piles or something, so we won't be doing pads. So we can design our attached beams, and yes, the attached beams can look strange. I'm going to up this to 16s, 420s, and that's all okay. And then in the bottom, I'm going to increase that from 16s to 20s, and that now is a solution that's working. If I come across to somewhere like here, we'll see also on my design of my L-beam, and I have quite a deep 450 deep slab because of those point loads from the upper floors coming down. It carried an upper floor plus a roof onto those that slab. On my upper levels, I then have a more traditional set of reinforcement, and you can see that I'm able to put 2 layers of reinforcement, and we can see our shear drag and everything for our design. And anything here that I see, I can say, well, would I get away with only 3 bars or 2 bars? And no, just using the mouse, I can change that. And we do have the auto design function as well. Column wise, so I said I wasn't doing the pads. Column wise, they're looking to be good, upper column, and that's looking to be good on upper column. So I can design all of my columns, all my beams, and the slabs were designed inside the FEA because that's an FEA criteria. And that is how simple it is to do the concrete design. We can analyze and design single members. So if I took this column, I could just analyze that and resize that, and it comes back correct. If I was just to go and change that from 16s to 8s and then resize, you'll see that it comes back saying we need 16s and 2 16s. You might get away actually with 2 12s. No, we wouldn't. We wouldn't get away with 2 12s per side because we are going to have a problem with our tie force check from the loads above and below. So I am just going to, for tension purposes, bring it back up to the 16s. and we can export that to DXF. We can print out our diagrams through into AutoCAD very straightforwardly. We can also interface with our Master RC program. So we've done our steel, we've done our concrete. We haven't saved anything, so we can go straight back into composite design, the third material. Fourth, if you consider the finite. So let's look just at, say, level 2. And again, secondary beams, failing, passing, or not passing, failing, and primary beams. So big primary beam here, and it's failing. I can ask it to go ahead and resize that, and it's going to attempt to do it, and it's not getting very far. I forgot I still have this 500 limit on my sections. It is working other than the natural frequency, but now guys, we can ignore that, as we would probably do a response analysis on the whole floor. So we have that facility. Naturally, you also have this showing up of all the unity values on the members I've already looked at. So scanning for failures would actually show up all the ones, or you can just pick them one at a time, and you can see some of these are working, some aren't, because we haven't gone through and done an official detailed design, including on all our edge beams. And we can do that quite easily, but time is of the essence. We can at any stage design web openings, so if you wanted to put an opening into a beam, you can, although in this case the opening would have been defined in the frame analysis area, so we will ignore that. And we have the libraries for all your types of deck profiles and studs, and you can create and add your own in here as you desire. So that's your composite design, and I'm going to come back out again without spending too much time. And what's left? Two things left in the design. One is our ability to come along and design the connections. So yes, we can design all the connections in our frame. So let's go in and use our connections. And you'll see again, just to save us some time and to get through, I have already set up some connections. So in my portal here, I have a nice big eaves joint. And if I just, there we go. So there's my eaves, and I can see my design. The only thing it's annoyed with, because my portal was actually very light, it's come up with very small sections, 127 by 76, because it's not spanning far and it's only 3 meter centers, so it's not that heavily loaded, and you probably wouldn't need a hunch anyway, but the bolts at 50 centers are a bit too close together. Let's look at something a bit more detailed. If I come down and look at a more typical connection, I think this is going to be in level 1 or 2. Yes, it is. On level 1, we are designing this beam to beam flexible end plate, and we can see that we can get away with just having 2 sets of bolts. And since there's room, I would just come along and say bolt geometry, vertical spacing, push them down to 90 just to give it a bit more of a look. We could obviously try and push that back to 70 and put in another row of bolts if we so desired. But we'll see that the thing is perfectly sound and working. Now, I can also just in search mode now see a more detailed design check on a column, and I will actually see that I am actually struggling in this case to design the bolts as a fin plate. So the fin plate connection is not very happy here. So what I'm going to do is I'm going to come along, turn off that smart menu, add another joint, and this time simple connection, beam to column, flexible end plate, and I'm just going to link it again directly to this member, and we should see that we get less failures. We do have 1 or 2 little problems and that is to do with the effective depth of these little end plates down here on the webs. So we would just need to come along and web left plate and say it's 200 deep, and then on the right plate say the depth is also 200, and everything's fine. And obviously there's just so much data here it's hard to see, but you can turn around and say only give me the web or the flange design, and we'll see our configuration there, or the column plan. So looking at this, we'll see that, you know, again we have this gap, but the way it's designed, it will work perfectly well. So that's your main criteria on your joints. Obviously one of the other nice facilities is the ability, if I look at one of my base plates and I come back out here to look at the full frame, you'll see that I am getting a green with others. So what I've done is I've linked this through to these, so that they're designing not just the one loading case, but in fact all the loading cases for all those members. So we're designing all of these all in one go, and we can see now that we have a little bit of a problem. It's just not happy with something, and it is a dimensional failure rather than a detail. So let's see what's wrong with it. Oh yeah, we've gone for 400, and these are huge columns. We need to go out to 500 wide so that we can get everything working fine. So base plate, although technically it would bear properly and there's no bolt tension, it's really annoyed because there's just no room to get the bolts in without them clashing. So 500 by 500, nice well spread out bolts, and everything now has gone white and is fine. And we're looking at our different cases for all the different joints. So we're looking at all of them, we're looking at all the different joints that are highlighted here in yellow, all at the one time. And we're able not just look at the one loading case, but actually look at all the different loading cases. And we can see that it's automatically now working perfectly fine and has no problems. So I just check my mic's still working. Yes, it is. I just hit my little switch. So that is all okay. So that's your connections, and I'm just going to close that down. Now, in this case I can save it because it's separate. The last design component is the timber. So let us go and look at a defined view of the plant room, and I can see that, for example, these little members are working, and we are using C24, and we're using a 38 by 122. So what's that? An old money, 1.5 inches by 5. We're down to the smaller sections, and we'll see they all work fine. And we'll see our beam here is with the flitched beam, and it is giving us all the design in this member, and then the bolts shear checks, the bearing checks, and the spacing checks. So we need 9 8mm bolts at 400 centers maximum, and then staggered above and below the line to get best benefit. So it's a very detailed, and if you zoom in here, you'll see actually that it is, and I've just lost the color on my plates. I don't know why. It should be showing up in the plate itself in blue, but not to worry. So timber, so steel, concrete, composite, timber, and connections, all in the one building environment. Your full wind load, your full gravity loads, bringing in from Revit, all of that in the one system, and doing your final elements. So just going to close down here and think about where we take this. And where we would take this is back into BIM, and we could come along and we can say, let's export this as an IFC and bring it into an IFC viewer, or into Revit, and we can link it to an existing. So I want to save the changes to the existing, submit the changes to the link, and export everything. So that's updating the link. And I actually have this model. So if I go to this, and it is this one here I want, and bring it in, and there's my model, I can actually go into add-ins, master frame link manager, and I can update the model from the link, and it's going to come along and it's little hourglass and update this existing model. So update levels, update elements. I'll leave the levels alone and just say OK. And it's no changed elements because I didn't actually do any change, and just say close. So it's updated the model in this case with no changes. Now I have gone through 8 or 9 different subjects here, and each one of these does have its own webinar on steel design, on composite, on connections, on BIM integration. So there are some great videos out there on our YouTube and website for you to get great benefit, more in the teaching rather than this showy display of your interface. So that's your BIM. We also have the ability to take a drawing and export it as GA drawings. So I can turn around and say, give me all of these, or in my case, maybe just level 2, or level 1, maybe level 2 actually. So let's just take level 2 or level 3, even level 3. And I can then say, I want it drawn A1 at 1 to 100, and I want to draw it as a wee simple stick outlines, and I want all my forces. I want my shear forces and any moments and any axials, and I want them on the beams only. And I want to have them such that I only know about shear forces over 75 kilonewtons, axial, so shear over 25, that was first was moment, shear, and axial over 50, and precision. So I can then export that, but I'm not going to again do that because AutoCAD itself, as you know, is very slow these days to load. So what I've done is I've done it already, and as we can see, we've got our members as little stick lines with their section size, our shear studs, and our mesh, and our shear reactions. These are all standard layers. As you can see, I can come along and I can turn on and off layers as I desire. So I could turn off my shear forces and therefore they disappear. I could turn off my what do you call them, mesh details. I can turn off whatever I want to keep this as nice and clean as I can. And that's just a simple DXF export. I'm in AutoCAD, but it could be any CAD package because we export in a basic format. So the only thing I have not covered here is vibration analysis, because it's not something you can really cover in a very, very brief, short time. So instead what I would do, I'm just going to close that, is I would point you, I'm just going to pull in my website. Under videos, you will see there are some excellent videos, and there's a fantastic video here that Dr. O'Gara, my colleague, has done on dynamic analysis. And it is, yeah, I'll just turn off that noise. I don't want to really hear him talking. It's more important to hear me. So you can go through and see dose values. You can see all about resonance build-up. You can see all about transient analysis. Everything here is covered in nice detail for you. So that is available to view at any stage on your dynamic analysis. This frame here is a slab with stairs, and we actually look at the response in one area due to the footfall in different areas, and it's a bit like saying, you know, will the operating theatre start to vibrate when people walk along the corridor outside. So that's all available to you. So I just want to summarise, and I think one of the best ways to summarise, I'm actually going to pause this, is to look at not the website but our little pricing program, our little pricing sheet. We have 3 different routes. You can go for your building designer suite, you can go for your PowerPad Lite, or you can build your own. Now the building designer suite is made up of our programs all bundled together very conveniently and in nice tailored systems, so you don't even have to think, so right, I want to do steel and composite buildings, so I would need the 3D model, 3D analysis and the steel and the composite. I don't need timber, I don't need connections, I don't want finite elements, and I don't do vibrations, so I don't need those. So I can get away with quite an economical solution. What you also have to remember is that the prices will vary. If you contact us, you will get them for your own country, and everything comes with a 12-month technical support, and also we do offer good discounts on additional copies. So if you want a second copy today, a second copy tomorrow, there is a very powerful discount. Now, some might say, why do we have this modular system? Well, just for what I've explained, that you don't have to take everything at once. But also, if you were networking it on a large system, you can make even greater savings, because this is a typical example of a multinational consulting engineers. They have 21 of our big analysis modules, but they only have 18 composite and 11 concrete and 3 steel. They only have 3 steel because it doesn't take them a long time to do their steel design. And the connections, they do those occasionally, and the dynamic for response and finite elements. So they were able to cut down the costs considerably. Now in my UK prices, if I was to buy 21 copies of all of this, it would be 200,000. You know, crazy madness. But by taking in both the additional price discounts and the modular basis, they're able to get that 21 user suite for only 88,000. Sounds like a lot, but that's coming in at a very, very competitive rate, considering the amount of programs, connection design, finite elements all coming into the one system. And then for your smaller consultants, you can see a similar style. And even for these fabricators who use our software extensively, they may do a lot of connection design, but they do a smaller amount of bit design and build, and in their case maybe only the one dynamic analysis. So it is modular and is designed to give you what you need for the minimum cost. It also allows you, because we don't penalise you for buying things later, it allows you to build up the system step by step. Start out with 1 copy, add your second copy, suddenly get a job that requires flow response spectrum analysis, add in your dynamic analysis, and away you go. So I'd like to thank you all for attending, but if you're interested and want a 30-day trial, just come along and fill in your details, and your details will go to your nearest reseller of the Master Series, and they will be able to help you with your 30-day trial. Or if you're in the UK and want to price directly, you give me a shout at tommy@masterseries.com, or even just sales@masterseries.com, and I will be able to help you out there.